Alright, so I want to make a rotary welding positioner, and I have a motor, and I've tried to make one before, but usually what happens is it ends up going too fast. I have a 3-phase 1/3 horsepower motor right here. This guy right here. And I've been having a hard time on eBay finding a gear reducer that has enough reduction. Anyhow, I found this thing online for $75. It's a 500-to-1 gear reducer. I don't know what this thing was originally used for. It says Merkel Korf Gear Company, Thoro Fine Stoker Drive. I'm too curious what's inside here, so I'm going to open it up first and see what's inside first, because I just have to know. Alright, so there's the inside. Little oil port here. Oil looks clean, that's a good sign. Okay, that little ring goes there. Wow. Okay. Oh, so it's planetary. Oh, interesting. Okay. So it looks like it's a planetary gear, then another planetary gear. And then it looks like there's a worm on top. I think that's a worm. So it's 1, 2, 3 different reductions, it looks like. So I think these lines here is to make sure that oil gets in there, inside here. Oh yeah, okay, there's the worm. So if I turn the input shaft, you can kind of see it doing its thing. Of course, we're only looking at 2 stages of the reduction. There's one more reduction, and that would be this. But you can kind of see how slowly it's moving. Put this over the spline, put this back in. So now when I turn it, see there's hardly any movement. That's what we want, lots of reduction. So I have a VFD controller for the 3-phase motor, so I can slow that down too if the reduction is not enough. I think it might still be a little fast. So, all right, so the goal here is to get this to go up here as tightly as possible. There was a flange here, an old mounting flange. I cut it off with a portaband, and then I machined this part flat. That's what it used to look like. And I'm going to machine the other side too, probably, just to at least get it flat. I just ordered a belt on McMaster, so yeah, I'm going to have a little, I got a 2-inch pulley, 5/8 bore here, and there'll be a belt that goes between here and here. And the idea is that this whole thing fits inside of this square tube. I actually think it's going to stick out. The back of the motor is going to stick out a little bit, but that's okay. The key thing was to be able to, be able to have the chuck in this position or this position. So as long as I do those two things, then I'm happy. This is the frame that I want to use to hold the gear reducer and the motor. This is a remnant that I bought, a scrap. Basically, it's an extruded aluminum square tube, 1/4 inch thick. Yeah, kind of an odd. So it's 8 inches from here to here. Kind of an odd, kind of an odd profile. The idea is to fit in the reducer in here, and it actually just fits. I had to machine off the top and bottom to make it fit, but it was already, it almost fit on its own. I had to take off about a 1/4 of an inch. So this now fits in here, just like this. So I'm going to bolt that. It has bolt holes on the bottom, so I'm going to bolt up into it from the bottom, and then the motor, this motor here, is going to go inside of it, and I'm going to have 2 pulleys. So that's how I'm going to transfer the power from here to here, 1 to 1. So I took apart this whole thing earlier, and I wasn't going to mess with the worm because I didn't want to pull it out. But I noticed that it was leaking from here, so I took the screws out here and pulled this thing off, and I noticed that the seal that they had in here was totally falling apart and crumbling. So that's probably why it was leaking. So here's the worm. Here's the worm I pulled out. Looks like it's in pretty good shape. There are a few little dings in here. I don't know what that's from, but otherwise it's pretty clean. This one has 3 starts, which is kind of interesting. I would have thought that it would have had only 1 start, considering that it's a 500 to 1. It seems like they would have just had 1 start, and then, I don't know, have the other gears have less reduction. But I'm sure there's a reason for it. All right, so here's the oil seal I got from McMaster this morning. I cleaned this thing out, and just gonna stick this thing in here, ready for a shaft. I drilled and countersunk holes for these bolts. And then I mounted on this hub right here to hold the chuck. It actually was a sprocket. I put it in a lathe, and I cut off, actually on a metal bandsaw I cut off the teeth, and then in the lathe I turned it. Anyway, it used to be a sprocket. Now it's a hub to hold the chuck. All right, so I stuffed a rag in there, and I'm just trying to clean this up a little bit. That dent I kind of filed it out. I'm just taking a little piece of sandpaper and flatten it. All right, that looks pretty good. I'm gonna vacuum this out, I think. All right, so I trimmed about, I don't know, an inch off the shaft, and I ground a flat spot here on the bench grinder. I'm pretty sure this thing's hardened, so I don't want to try to, you know, screw up an end mill trying to do that. So I think that'll be fine. And this is the pulley. It goes on here. It goes on there like that. All right, that's the bottom. All right, so I got figured out a way to push this thing on. It just happened to have some of the stock sitting around. I cut it down. This is 5/8. The inside hole is 3/4. So I'm going to put it in the vise and push the bearing down. And I got a little piece of Delrin in here so I don't smush up the end of this thing. Fortunately, the vise has the range to do this. Ooh, tight fit. Oh, there we go. There we go. All right, I had trouble getting on, but yeah, now it's on. That spins freely. So there we go. Just want to make sure the silicone's got something to stick to. And the grease and the oil isn't going to interfere with the gasket, with the seal. All right, I'm going to put some lithium grease on here. I don't know if that's the right thing to do, but you gotta have, I feel like you probably should have some kind of lubricant before I put the seal on. That's my hunch. All right, so let me get this started, okay. So in the directions, they say not to torque it down all the way. All right, I get this hub mounted. Now I'm gonna put on the chuck. So here it is, almost done. You can see the motor hanging out the end there. When I originally designed this, I thought that I didn't think it would have to be that long, but anyway, you kind of see it hanging off the edge there, but I did make it work. I put the chuck on, and if we take a look inside, I cut out the slot here to give me access, you know, to put the belt on and just kind of see, for alignment and just kind of see what's going on. Anyway, I got a 2-inch pulley on the gear reducer, and then on the motor end I have a 1.5-inch pulley, so I have a little bit of reduction before it even gets into the reducer. I I found that even with 500 to 1, there are some cases where it might be a little too fast. So anyway, so I put that in there. The 2-inch gear reducer I didn't have a 1.5 inch gear reducer, so I turned down a 2-inch one and made it 1.5 one. So there's the pulley, the 2 pulleys, and then the belt. And I've wrapped this around here a couple times. I know it's not ideal. I kind of wanted to make this with the brushes built in, so I wouldn't have to do any of this, but I looked into it and I just didn't want to deal with it, so this is how I did it. Not too bad. Again, certainly better than trying to do it by hand. You know, I found myself wanting it to go, wanting the piece to move a little faster while I was welding. So I think what I'll probably end up doing is having make a foot switch. Well, not a switch, but some kind of a pedal that has a potentiometer built into it, and then just have that talk to the VFD, and that way I can kind of like change it on the fly. This is a variable frequency drive, so it takes single phase 120 volts and it converts it into 3-phase 240 volts. So what that allows me to do is to change the motor speed. You know, what I'm doing with this is changing the frequency, you know, so right there it's at 27 cycles, 27 hertz. So that's how I slow the motor down, is by changing the frequency. You can reverse it, you can change the frequency. This goes all the way up to 60. So 60 would just be the standard 60 hertz for 3-phase power, and you can go all the way down to, I think, 1. So right now it's running at half power, so I can make it go, I can make that thing turn twice as fast as it is now. Alright, so I'm going to try to weld on this thing again. I think I've got the motor speed control figured out. The idea was to be able to control motor speed manually while I was welding to get it right, instead of setting it up and then trying to weld and kind of hoping. So what I did was, on the VFD I have here, I put some control wires in here. So the black and the white wire, that's kind of on off, and then 2, 5, and 6, that goes to a potentiometer, and that controls the actual speed. So you can turn it off, turn it on and off, and then you manually control the speed. And I did that with this guy right here. Right now I have it hooked up to my MIG welder. It's supposed to, this came with my TIG welder that I bought from Miller, and I've never tried to TIG weld with this thing. I prefer using my feet to control my TIG welder, but anyway, this came with it. It didn't actually come with a foot pedal. I had to buy this thing. I bought it off eBay, actually. These are like $400 new. So I realized that I've got this little guy. So I cut the wires, figured out which wire did what. It has the same function, on, off, and then a pot to control speed. So anyhow, I'm gonna here, I'll show you how this thing works. So right now it's off. If I turn it on, I just go down. Now it's on. Right, so it's building up speed. Okay, so that's basically its maximum speed. So let's say I'm welding and that's too fast, right? So I'll be like, oh, gotta slow it down. I bring this thing down, and the whole thing slows down a little bit. Anyway, I'm gonna weld and show you guys what I mean. All right, here we go. So I'm just going to kind of try to pretend and see how it feels. I'm happy with this. And this is a 14 gauge. Looks like it works okay. Up here, keep going, and then I blew out here, and then anyway, I just stopped. Anyway, so this is the kind of thing where you got to kind of mess with it and get your settings the way you like them, and get the speed the way you like them. Changing speed on the fly. It works, but it seems like it's a better bet to just kind of figure it out ahead of time and figure out what works. Anyway, so yeah.